Welcome to the School of Life. Life is hard, but you have got to be harder. I'm Mrs. Collins, your life coach. Let's get started with Unit 2, Lessons 3 through 6 quiz review. On the quiz, you'll be asked to do a few different things. Very first thing, you'll be asked to write equations of parallel and perpendicular lines. Please use this document as a guide to help you with writing the equations. Remember the differences between parallel and perpendicular lines. Parallel lines have the same slope or equal slopes, and perpendicular lines have opposite reciprocal slopes. Here gives you different examples of both of those relationships. So please look at that document. Also on the quiz, you'll be asked to classify quadrilaterals, and there's two important documents that you'll need to pull up. One is this one that shows you, if you're given certain lengths, what your possible quadrilaterals are, as well as this one that, again, given certain lengths as well as whether or not you have parallel and perpendicular sides. This document will help you to narrow down and determine which quadrilateral you are looking at. Lastly, the things you will also need on the quiz are your slope formula, which is m equals y2 minus y1 over x2 minus x1, and you'll need your distance formula, which is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Number 1 comes from lesson 3. We're asked to write the equation of the line that's perpendicular to y equals negative 3 over 2x plus 5 and passes through 3, negative 5. Key word here is perpendicular, so we should think opposite reciprocal slopes. So if we look at our original equation, y equals negative 3 over 2x plus 5, our slope here is a negative 3 over 2. So for our new line, because our key word is perpendicular, our new line should have a slope that's the opposite reciprocal of negative 3 over 2. So instead of negative 3 over 2, it becomes a positive 2 over 3. So our new line has a slope of 2 over 3. We're also given that this new line goes through the point 3, negative 5. So 3, negative 5 is something else we know about the new line. If we're trying to write our equation, the last thing we don't know is what is our b, which is our y-intercept. So what we do is we solve for it. So we have y equals mx plus b. We're given our x and our y from our ordered pair, and then we also have our slope, which is m. We plug in all those knowns into our equation, y equals mx plus b, and we'll have negative 5 equals 2 over 3 times our x, which is 3, and then plus our b. If we are multiplying 2/3 times 3, 2/3 times 3 will leave us with 2 plus b equals negative 5. Subtract 2 on both sides, and we're left with b equals a negative 7. So b is negative 7. So to write our very last equation, we'll have y equals the m we had for our problem is, or for our new line, is 2/3, so 2 over 3 x, and then we found out that our b is negative 7, so minus 7, and this is our final answer. Number 2 comes from lesson 4. We're writing the equation of a line that's parallel to 6x plus y equals 16 and passes through 8, negative 5. This first equation is not in slope-intercept form, so our first job will be to do some side work and solve this equation for y so that it's in slope-intercept form. So side work This is our first step. We have 6x plus y equals 16. Solving it for y will require us to subtract 6x on both sides. And we have y equals negative 6x plus 16. So this equation, if we want to rewrite it, you can actually rewrite it as y equals negative 6x plus 16. That's the one we're going to look at. But we look at our keyword in our problem. It's parallel. So by the fact that we have a parallel line, that means that we'll have the same slope. Our second line will have the exact same slope. So as we're writing down information about the new line, it should have a slope that's the same as the original. And our original, the slope is a negative 6. So therefore our slope here will be a negative 6. And we know that it goes through the point 8, negative 5. And so now let's come up with our equation. So we have y equals mx plus b. Plugging everything in, we have our x and our y from our ordered pair. So negative 5 equals, our slope was negative 6, times our x, which is 8, and then plus b. Negative 6 times 8 gives us a negative 48 plus b equals negative 5. Adding on 48 to both sides, we end up with b is equal to 43. So our b is 43. So therefore our final equation is y equals negative 6x plus 43. All right, next we have number 3. Classify quadrilateral MATH. This comes from lesson 5. So if you need to go back and reference it, it's in lesson 5. For quadrilateral MATH, the first thing you want to do is kind of draw out your rough sketch of a quadrilateral, simply a four-sided shape. So we have MATH. Remember, wherever you start your first letter, which was the first vertice or corner within our quadrilateral, you want to then go in a clockwise motion to list the rest of the letters. So M-A-T-H. So M-A-T-H. From there, I'm going to go ahead and write in the measurements for each side. It tells us that MA is the square root of 65. AT is the square root of 65. TH is the square root of 65. And HM is the square root of 65. For this, you'll need to use your two documents from lesson 5. So make sure that you use them as a reference. One thing that we do first is look at the side lengths. Well, what do we notice about the side lengths? You should notice that all four sides are exactly the same. They're equal. So since all four side lengths are equal, you're able to determine or narrow the possibilities down to just two shapes. This is either a square or a rhombus. Square or a rhombus, one of the two. The next thing we'll do is think about the characteristics of a square versus a rhombus. Both of them have two sets of parallel sides. So let's look. We have parallel MA is parallel to TH. And we have AT is parallel to HM. So since both of them have two sets of parallel sides, this really did not help us to further narrow and figure out whether this is a square or a rhombus. But if you can recall, a square, and as well as if you go back in your notes, a square has perpendicular sides. Perpendicular means that we have opposite reciprocal slopes. So let's see if we have any opposite reciprocal slopes here. So we have 2/3 and our negative 3/2. 2/3 and a negative 3/2. Are these opposite reciprocals? Well, 2/3, if you flip it, it becomes 3/2. 2 over 3 is positive, while this one is negative. These are opposite reciprocals. So yes, opposite reciprocals. So that means that they are perpendicular. And a square is the one that has the perpendicular angles. So these should be right angles. Note that again, my object is not drawn to scale, but it should have right angles there. So because of that, we know that this is a square. And your reason for how we know is there were 4 equal sides. And we have perpendicular sides. Okay, if you want to also list that there were parallel sides, that's fine. But the key thing again that made this a square instead of a rhombus is the fact that it had perpendicular sides. Those perpendicular angles in there created this square, or the square. The characteristic for a square is that it has perpendicular angles. In other words, you have 90-degree angles. All right, and our last question, number 4, comes from lesson 6. And it says, find the length and slope of each side, then classify the quadrilateral and explain how you know. Very first step for this one is to go ahead and plot your points and as well as label them. So A, B, C, and D. The next thing we needed to do is write down the sides. So we've created side AB, we've created side BC, side CD, as well as side DA. So we have our sides. Your next step is to figure out your lengths and then our slopes. So on the side, I've created the following for our side work. So side work, we need to first find the distance for A to B. And I've listed my 2 points, 1, 1 and -2, 5. I can go ahead and write in x1, y1 and x2, y2. And then go ahead and make the calculations. So we have -2 minus 1 squared plus 5 minus 1 squared. And this gives us the square root of -2 minus 1 gives us a -3 squared plus 4 squared. -3 squared is 9 plus 16. 9 plus 16 is 25. So we have the square root of 25, which is equal to 5. Side AB is 5 units long. For side BC, we have again our x1, y1, x2, y2. Using our distance formula, you have 3 minus your -2 squared plus 5 minus 5 squared. This equals 3 minus -2 is 5 squared plus 0 squared. 5 squared is 25, 0 squared is 0. So this gives us simply the square root of 25, which is 5. So side BC has a length of 5. Side CD, we have x1, y1, x2, y2. Plugging it all in, 6 minus 3 squared plus 1 minus 5 squared. 6 minus 3 gives us 3 squared plus 1 minus 5 gives us a -4 squared, which is equal to 9 plus 16, which gives us once again 25, which is equal to 5. The square root of 25 is 5. So 5 units long for side CD. Side DA, we have x1 and y1, x2 and y2. Plugging it all in, we have 1 minus 6 squared plus 1 minus 1 squared. This gives us the square root. 1 minus 6 is a -5 squared plus 1 minus 1 is 0 squared. So this is 25 plus 0, which gives us a square root of 25, which is 5. So our answer here is again 5 units long. So for each of our 4 sides, our lengths are 5, 5, 5, and 5. Next, we calculate the slope for each of the sides. So we begin with the slope for side AB. We can label our points, x1, y1, x2, y2, and then subtract our y's, 5 minus 1 over negative 2 minus 1. 5 minus 1 is 4 over negative 2 minus 1 gives us a negative 3. So our slope is m equals 4 over negative 3 for the first one. For the slope of BC, once again labeling our points, x1, y1, x2, y2. We'll have 5 minus 5 over 3 minus negative 2. 5 minus 5 is 0 over 3 minus a negative 2 gives us 5. 0 divided by 5 gives us a slope of a 0. So we have a 0 slope. For CD, again labeling x1, y1, x2, y2. And we have 1 minus 5 over 6 minus 3. So that's negative 4 over 3. So once again, our slope is negative 4 thirds. And lastly, the slope of DA, we have our x1, y1, x2, y2. So we have 1 minus 1 over 1 minus 6. This gives us 0 over negative 5, which gives us a slope of 0. So if we fill that into our table, we have a slope of negative 4 thirds, 0, negative 4 thirds, and 0. Okay, so with this information, we're able to we have enough information, whereas we can narrow down the quadrilateral that this represents, and then figure out exactly which quadrilateral this is. So first, we have our lengths. All 4 sides are the same. All 4 of our sides were exactly the same. The shapes, whereas all 4 sides are exactly the same, are a square and a rhombus. So this answer is either a square or a rhombus. Square or a rhombus. Well, if this is a square, then that means that we'll have perpendicular sides. If we have perpendicular sides, then we need to look for some opposite reciprocal slopes. If you look at your sides that are right next to each other, the negative 4 thirds and the 0, these are not opposite reciprocals. So therefore our answer, this cannot be a square. We have no right angles. This must be a rhombus. So our answer is a rhombus. And that concludes our review for your Unit 2 Quiz 2, which will cover lessons 3, 4, and 5. If you need to practice more problems, you can find them within your assignments, and then just practice the problem and look at your answer keys for them.